All right, we finished chapter 11 last time. Any questions over chapter 11? Now we're going to start chapter 12. We're on the final stretch. We only have chapters 12, 13, 14, 15, and 16 to do. There are a couple of them that have 7 sections, but most of them have 4 or 5 sections. So it's going to be a repeat of a lot of stuff we've done already. We'll just go one step further. All right, chapter 12 deals with equations, inequalities, and the applications of equations and inequalities. Section 1 deals with the addition property of equality. Section 2 deals with the multiplication property of equality. And then section 3, we go a little bit further in other techniques in solving linear equations. First off, what is a linear equation? How can you tell if the equation you have is linear or not linear? Good answer. No exponents or other special operations on x. X is not in the denominator. Basically, it looks like this. Where A, B, and C are any integer, any numbers, decimals, fractions, numbers. When we talk about a solution to a linear equation, what are we talking about? When you say solution, what does it really mean? A number or set of numbers that make the equation true. Solution is a number or set of numbers that makes the equation true. What does that mean? If we have the equation x plus 3 equals 5, we know that the only way this could be true is if x equals what? Yeah. If x equals 2, then we can test it. 2 plus 3 equals 5. 5 equals 5. That's a true statement. So in other words, it's a number or set of numbers that make both sides of the equation equal to each other. So that's a solution. A solution set is the set of all. That sounds circular. A solution set is a set of all solutions. Duh. But this is how it looks. Whenever you see those squiggly lines, that means you're talking about a set. So whenever you ask for a solution set, you're supposed to put whatever answers you have inside the squiggly lines. That's a solution set. If you ask for a solution, then just tell me what the variable equals. All right, now let's talk about equivalent equations. Equivalent equations. What do you think equivalent equations are? And what makes them equal to each other? Yes, you're right. I mean, yes. With the logic they had earlier, yes, you're absolutely correctly. But they're equations that have the same what? If they're equal to each other, they have to have the same what? Yes, but what values? The exact same solution sets. So if two equations are equal, that means the answers of both of them have to be equal. But you're right. You said when you said the values, that's what you meant. I know, but we have to put it in math terms. All right. So let's look at this. Let's first define what we mean by the addition property of equality. It's also called the golden rule. What's the golden rule? Yeah, in your own words. What's the golden rule? Think of if you ever went to religious education. In mathematics, it's this. If A equals B, B can be any numbers. But if A equals B, then if I add a number to A, I have to add the same number to the other side. Whatever you do to one side, you have to do to the other. The golden rule is do unto others as you would have them do unto you. All right, so this is the additive property of equation. Whatever you add to one side, you have to add to the other side because they have to be equal. And we could see equality as a seesaw. I know kids don't play with seesaws anymore, but it's a balance. Whatever you put on one side, you have to put on the other side to keep the balance. Does it work with subtraction also? Yeah, well, it should. If I take away, if A was 10 pounds and I took away 3 pounds, wouldn't this have to be equal also? If A is 10 pounds, then what's B? Also 10 pounds. So if I took away 3 pounds from A, I got to take 3 pounds away from B. So yes, it works for subtraction as well. But what's the difference between the addition and subtraction part? What does addition do to a number? Yeah. Addition makes it bigger. Subtraction makes it smaller. When solving equations, we want to isolate a variable. How do we do that? Move all, I'll call them x's, to one side and all non-x's to the other. Side. Because when you're solving for a variable, you want to get that variable by itself. That your whole objective is to isolate it. Get it by itself. Isolate a variable. Isolate means to get it alone. So we have to first move the variables away from the numbers. Then we have to remove any coefficient. Of x. What is a coefficient? Or, yes, it is outside the parentheses, or where? You're right, it's, if I had this is a coefficient. But if I distribute this is also a coefficient, the number in front of the variable. So yes, it's in front of the parentheses, but it's also the number in front of a variable. That's also, these are coefficients. All right, let's give you some examples and you tell me what the coefficients are. Okay. Here's the number. Tell me the coefficient. Yes. Everything has a 1 in front of it. Very good. Hmm? Okay, let's look at this. We know since there's no number in front of here, what number is automatically there? A 1. So anytime you have X over any number, you could separate those like that. So if you had 2x over 5, what's the coefficient? Now you could separate those, so this is your coefficient. All right, so we're going to need to know those in the next section about multiplication, because that's how we get rid of these things. So solve this. Remember the steps. We have to isolate the variable. Are all the variables on one side? Yes, all the variables on one side. So we have to get rid of all the non-variables. So we have to get rid of the 5. How do you get rid of the 5? Yes, do the opposite. Whatever's in front of it, do the opposite. That's a plus, I need a minus. So 5's cancel. 5 is bigger than 2, it's negative, so the answer is negative. 5 minus 2 is 3. Always check your answers. CYA. So my equation was x plus 5 equals 2. I'm saying that x equals negative 3. So plug it in there. Anywhere I see an x, I put a negative 3. 5 is bigger than 3, it's positive. 5 minus 3 is 2. It checks. So what's my solution? My solution is x equals negative 3. My solution set is squiggly line, negative 3, squiggly line. I know you all, next to fractions, decimals are the least favorite numbers to deal with. Okay, so let's do this. When dealing with decimals, first step, remove the decimals. x minus 2.9 minus equals negative 6.4. Now, the question is, how do you get rid of the decimals? Negative. Find the smallest decimal. Well, what is the smallest decimal? How do you know what the smallest, what I mean by that is 0.2 is bigger than 0.02. The more spaces it has between the decimal and the numbers, the smaller it is. So 0.002 is less than 0.002, which is less than 0.02, which is less than 0.2. So you see this, the more decimals it has, the smaller the number. The decimals to the left of it. Determine the number of spaces needed to move the decimal behind the first non-zero number. Determine the number of spaces needed to move the decimal behind the first non-zero number. So in our case so when we get the decimal there, it's both of them are only one space. Each space equals 10. Each space equals 10. Multiply that number to each term in the equation. Yeah, the writing part is boring, but once you see it, it makes a lot of sense. It's super easy. It's just the writing it out makes it more difficult. Once you find the most spaces you have to move, each space you put another 0 behind that 10. So now multiply that number to each term. So we multiply, since we only have to move one space, then we multiply the whole equation by 10. Each term by 10. So I'll put a 10 in front of each term. You notice how I put the 10 after the minus sign? Because I'm multiplying to the number, not the sign. I'm not going to change the sign. So we have 10x, negative times positive is negative. What is 10 times 2.9? Every zero you have here, that's another space you move it to the right. Every zero that you have that you're multiplying by is one space to the right. So 6.4 only has 164. So we get rid of the decimal. Now we're done with the decimal. We don't need it anymore until the very, 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 very end. Are all the x's on one side? Yeah, all the x's are right here. So we have to get rid of what number? The negative 29. Since all the x's are here, all the non-x's have to go to the other side. How do you get rid of negative 29? What? You do the opposite. Add 29 to both sides. Negative 29 and 29 cancel. So I have 10x equals. Since the signs are different, take the sign of the larger number, which is 64. Answer should be negative. 64 minus 29. 5 minus 2 is negative 35. Is the x by itself? No, it's connected to the 10. How is it connected to the 10? What operation is going on here? Multiplication. There's no plus sign, no minus sign, no division. So what's opposite of multiplication? Division. So we have to divide both sides by 10. So here's the decimals behind the 35. Since I'm dividing by 10, the number of zeros down here means I move it to the left now. When you multiply, you move it to the right. When you divide, you move it to the left. So the answer is negative 3.5. Yes. Yes, because when you divided something, it makes it smaller. The further to the left the decimal, the smaller the number gets. And that's what I'm going to show you right now. I'm going to just show you multiplication division by tens and hundreds and thousands. $47.2 divided by 100. Since I'm dividing, which direction do I go? Left. Okay. Division, you go to the left. Multiplication, you go to the right. Because when you divide, you make it smaller. Each zero is another decimal space. Since I have two zeros, I move it to the left 2 decimal places. So my answer is 0.472. What's that one going to be? Yeah, Where's the decimal now? It's after the last non-zero number. So since I'm dividing, I move it one space to the left. So it's 62.5. Each zero is another decimal space. How about that one? Yeah, because we move it 1, 2, 3 spaces. Since we're dividing, 3 spaces to the left. 1, 2, 3. So it's negative 0.34275. Let's look at multiplication. We already know this part. Actually, if I had 2 times 10, what does that make it? Y20. Because it's, where's the decimal in this number? Yeah, it's actually 2.0. 2.0 times 10, I move it over one space. That's where it becomes 20. $35.42 times 1,000. How many spaces do we move it? Which direction? Yeah, 1, 2, 3. Since it's multiplied, we go to the right. So 1, 2, 3. So we have 35,420. Because I have to put another space there. So yeah, again, if I had 2, this is 2.0 times 1,000, what would it equal? 2 times 1,000 is what? 2,000. If you look at it, I moved it 1, 2, 3 decimal places. 1, 2, 3 decimal places. So when you're multiplying, you move the decimal to the right. When you're dividing, you move it to the left. So multiply, move decimal to the right. Divide, move decimal to the left. Do it there. We have decimals everywhere. X plus 2.451 equals 3.42. So how many zeros does your number have to get rid of the decimals? Which is the most number of decimal places? There's 3 of them. There's 1, 2, 3. We have to move the decimal behind the number. So this one only has to move 2 times. This one has to move 3. So we have to move it 3 times to get rid of the decimal. If we have to move it 3 times, what number do we multiply by? Yeah, we need 3 decimal places, so it's 1,000. Each 0 is a decimal place. So we have to multiply this entire equation by 3 zeros, which is 1,000. Do you understand? You ever follow that? Because I'm seeing the front row looking like a car's about to hit them on the road. Does it make sense? You don't look at this one. This only has 2 decimal places. This one has 3 decimal places. I have to move the decimal 3 spaces. So I have to multiply each number by that. So 1,000 times x is 1,000 x. 1,000 times that, 1, 2, 3. So it's 2, 4, 5, 1. I move the decimal 3 spaces. 1, 2, 3. So that becomes 3, 4, 2, 0. Because you have to move the decimal to the right 3 spaces. I have another space I put right there. Now the decimals are gone, we just treat it like we normally do. What do you do next? Yeah, we have to get rid of this one. Move the non-x's to the other side. So that's plus, I got to subtract 2, 4, 5, 1 from both sides. 2, 4, 5, 1. Zero minus 1 you can't do, so I got to borrow 1. 10 minus 1 is 9. Bless you. 1 minus 5 I can't do, so I got to borrow 1. 11 minus 5 is 6. 3 minus 4 I can't do it, so I got to borrow another 1. 13 minus 4 is 9. If you don't remember your subtraction rules, please review them. Practice. This is how bad calculators have made our brains. Next step. No, we're not done yet. Is x by itself? No, it's got 1,000 in front of it. How do you get rid of 1,000? Yeah, since it's multiplied, we have to divide by 1,000 both sides. Since I'm dividing by 1,000, which direction do I move the decimal? To the left. The decimal right now, since there's no decimal there, it's automatically after the last digit. So I got to move it 1, 2, 3 spaces to the left. 1, 2, 3. And there's your answer, 0.969. In front of it, yes. We have to move it another space. So we put a 0. So 0.0969. Yes. Yes, for every space that's not there, we have to put a 0 there to hold it for us. Good question. I'm glad you asked that. So far, so good. Let's try fractions. I know y'all like fractions. First off, let's try a fraction like this. x over 2 equals 3. It's the same concept. We have to isolate the x, move all the x to one side, non-x to the other side, and get rid of anything around x. So there's nothing here plus or minus, so we have to get rid of the 2. How do you get rid of the 2? How is x and 2, how are they connected? This is division. What's the opposite of division? Multiplication. So what do we multiply by? 2. Whatever you do to one side, you have to do to the other side. So remember, this is actually a fraction. On this side, it has to be a fraction. Because what is the coefficient of x? So the 2's cancel. So we have x. 3 times 2 is 6. And again, check your answer. 6 divided by 2 is 3. So it works. So my solution is x equals 6. There's one thing I forgot to go over. Let's solve this one. 4x minus 3 equals 5. So my first step is what? Yeah, are all the x's to one side, first off. That's the first thing. Are all the x's to one side? Yes. So if that's everything else has to go to the other side. So we have to get rid of this 3. How do you get rid of the minus 3? Add 3. Exactly. Good job. So you add 3 to both sides. So we have 4x. 5 plus 3 is 8. We want to get the x by itself, so we have to get rid of the 4. How? Very good. Because these are multiplied, we have to divide both sides by 4. 8 divided by 4 is 2. And there's your solution. Good job. And what do you do with this? Check it against that one. So it's 4 times 2 minus 3. Does it equal 5? 4 times 2 is 8. 8 minus 3 is 5. There. There's your equation. It works. So your solution is x equals 2. Any questions so far? Because now two x plus 3 equals 5x minus 6. Now we have x's on both sides. What do you think we do here? You have to put the x's together. Which one do you move where? Good job. Always move the smaller x to the larger x. Why? So you don't get a negative coefficient. Very good. So since we have the first thing we look at are the x's, we move the smaller x to large. So we have to get rid of this 2x. How do you get rid of 2x? Subtract 2x from both sides. So 2x's cancel. 5 minus 2 is 3. Okay, we have our x's to one side. The coefficient is positive. That's a good sign. So we have to get rid of what? We have to get rid of the -6. Because we have all the x's to one side. Everything else goes to the other side. So what's the opposite of -6? +6 to both sides. 3 + 6 is 9. And the last step, divide both sides by 3. So x equals 9 divided by 3 is 3. And always get used to checking your answers to make sure they're valid solutions. Let's see if this is a valid solution. Let's put it back in your equation. We have 2x + 3 on this side, 5x - 6 on this side. We're saying our answer is 3. So anywhere you see an x, put a 3. And work out both sides. 2 times 3 is 6. 5 times 3 is 15. 6 + 3 is 9. 15 - 6 is 9, so it works. So far, so good. True or false? Are both of these things equal? I should even do this. It's true. I'll show you. Let's look at this. How do we make x positive? Well, if we add x to both sides, these cancel. And I have x plus a. How do I move the a? What do I have to do to get rid of the a? Subtract a from both sides. So what does this rule here tell us? What does that rule tell us? That's what I've been telling you all along. If you have a negative in front of the x, just change the signs across the whole equation. I change the sign from negative to positive. I change the sign from positive to negative. It's going to be equal equation. So if the x has a negative coefficient, change the signs across the entire equation to get rid of the negative, and then isolate your x. It's just changing the signs a lot easier than going through this whole process. Okay, let's look at an example here. Three minus x equals 5. What do you do first? All the x's on one side, right? So let's get rid of non-x's. Let's get rid of the 3. Since that's positive, we have to subtract. 5 minus 3 is 2. There's a negative coefficient in front of x. So what do you do here? Just change the signs and you're done. That's what I just showed you here. If I was to do this algebraically, I have to move the negative x to that side. So I add x to both sides. I have to get rid of the a. How do I get rid of the a? By subtracting the a. So I'm changing the signs by moving them around. Instead of wasting my time doing that, I could just go ahead and just change the signs and I'm done. Negative 3 minus 2x equals 5. Well, yeah, since all the x's, remember the first step, let's look at the steps. First step, isolate x. Is x on one side? Check. Move all non-x's to other side. So yes, we have to get rid of this negative 3 by adding 3 to both sides. Five plus 3 is 8. If a negative coefficient change signs. Or if there's a negative in front of the coefficient, just change the signs. Both sides. On both sides. I know most of you all were taught divide by -2 to get, never divide by negatives because you will make more mistakes doing that than anything. Negative signs are the most common mistakes in math. In other words, then if you can get rid of them early, then you'll increase your chance of making a better grade. So when you get to negative here, now what do you do? Isolate the variable. Divide by 2 both sides. X equals, answer is negative. 8 divided by 2 is 4. There. Getting better at this? Okay, let me give you a bigger one. Change topic, she's back. Just kidding. Are you ready for a bigger one? With negative signs everywhere. 8 minus 6x equals negative 7x plus 5. All right, we have x's on both sides. Which one do you move where? Which one's smaller, negative 6 or negative 7? Negative 7 is smaller. So we move that by adding 7x to both sides. Move the smaller x to the larger. So we 7 minus 6 is 1. It's positive 1. We have the x's on one side, so we get rid of the non-x's. Get rid of the 8. Subtract 8 from both sides. Eight's bigger than 5, it's negative. 8 minus 5 is 3. Negative 3 is your answer. Always, always, always check your answer. So wherever I see an x, I put a negative 3. Put negative 3 in those two places. So work it out. Negative times negative is a positive. 6 times 3 is 18. Negative times negative is a positive. 7 times 3 is 21. 8 plus 18 is 26. 21 plus 5 is 26. So x equals negative 3 is the answer. Check your answers before you submit them. So you were doubting yourself. Yes. Both sides have to be up because we have two separate equations with x. So we plug into x in there, and if both sides are equal, then they're called what we call equivalent equations. And that's the only way we can test to see if they're equal. What's that? No? Oh yeah, it's just the easiest way. That's why I tell my students is even before we had computerized tests, I said before you ever show the test to me, you should know whether the answer is right or wrong if you tested it. Three x minus 12 plus x plus 2 equals 5 plus 3x plus 2. Go ahead and work that. Okay, let's look at the left side. Here we have an x, here we have an x. What's the number in front of here? So we have 3 plus 1 is 4x. We have a negative 12 and a positive 2. The 12 is bigger, so the answer would be negative. 12 minus 2 is 10. Here we have 5 plus 2 is 7. So whenever you solve equations, make sure you simplify both sides as far as possible before you move everything over. Now what do you do next? You have 4x minus 10 equals 7 plus 3x. Which number do you move where? Right, moving the smaller x to the larger. always move the x's first. Those are the important ones. Since that's a positive 3, I subtract 3x from both sides. Four minus 3 is 1. Minus 10 equals 7. Then add 10. So x equals 17. That's the answer. I was just testing your confidence.
I was confident in check it, and I did not.
Okay, let's test it. Let's check it. Yeah, right. There's a second part of the problem is you have to make sure you check it correctly. Then I'm going to show you a shortcut in these type of equations. All right, so we know that x equals 17, or we want to say that x equals 17 is our answer. 3x minus 12 plus x plus 2, 5 plus 3x plus 2. We're saying x equals 17. So anywhere I see an x, I put a 17. So I put 17s in there. Let's work the left-hand side. 3 times 17. So 3 times 7 is 21. 3 times 1 is 3, plus 2 is 5, 51. Minus 12, plus 17, plus 2. 51 minus 12. 1 minus 2 you can't do, so you have to borrow 1. 11 minus 2 is 9. 4 minus 1 is 3. $39 plus 17. 9 plus 7 is 16. 3 plus 1 plus 1 is 5. 56 plus 2 is 58. So we're hoping this side will return to 58 also. We know 3 times 17 is 51 from this side. 5 plus 51 is 56. 56 plus 2 is 58. Was it just because there's a lot of numbers? Treat each pair of numbers at a time. Remember this first rule I put on the board? If A equals B, and if I add C to both of them, remember that? It's going to be equal, right? Let's go backwards. If I start off with this, I end up with this. So if I have an equation, and on both sides of the equation, I have the exact same thing, I can get rid of it. If I get rid of the same thing on both sides, I still keep equality. True or false? If I get rid of the same thing on both sides, I haven't changed it. I just changed the way it looks. It's still equal. Let's look at our equation. What is the same on both sides? Well, here's a positive 3x. There's a positive 3x. I can get rid of both of those. Because if I subtract 3x on both sides, they're gone.
like when you put that, they're not simplified, because it's like right off the bat.
No, it's no, it confuse them. You're always supposed to, because the first rule is, we're gonna start looking at the next ones, is whenever you have large equations, always simplify both sides before you start moving things around.
Like, when they're on like multiple x on one side, other than that, they should like, to not simplify, they break down the colors, like.
No, so,
it'll give you different answers.
no, it won't. Math, see, the beautiful thing about math is if you follow the rules, there's only one right answer. If you follow the rules of math, you'll always get that answer. But to make things easier for you, we'll combine what we can first. Combine these two, make it a smaller equation here, make it a smaller equation here. Treat them all separately and then combine the whole thing. Yeah, so again, what your high school teachers taught you before, forget. When you come in here, forget that. They read the book wrong.
And do like, when simplifying and then not simplifying, they two completely different answers, and you can go through like on.
And that's what multiple choice tests are usually that way, is because they will look at most common mistakes students make. And that's why you always simplify first. It's one of the basic rules of math, is always simplify before you go any further. So now, if you have the same thing on both sides, you can get rid of it for equality pace. Is there anything else that's the same on both sides? Get rid of the twos. They're both positive twos. So if I subtract 2, now if we solve this one, we add 12 to both sides. So when you look at your equations, if it's exactly the same thing on both sides, adding and subtracting, if it's exact, get rid of it, because they did the same thing. So I made it smaller that way. Okay, let's look at, yeah, that's a shortcut. Let's look at with parentheses. Four times x plus 1 minus, in parentheses, 3x plus 5 equals 1. Order of operations. Can we do anything inside the parentheses? No, we can't do anything inside there. So we have to get rid of the parentheses. How do you get rid of the parentheses? What's that property called? Distributivity. Remember, distributivity was this one. If you have a number out in front, you multiply it to everybody inside there. Right, yes. So positive and positive, positive. 4 times x is 4x. Positive times positive. 4 times 1 is 4. Negative times positive is negative. There's a 1 here. 1 times 3 is 3x. Negative times positive is negative. 1 times 5 is 5. Whenever you get rid of parentheses, always combine like terms next. Whenever you get rid of parentheses. 4x minus 3x. So 4 minus 3 is 1. Positive 4, negative 5. 5 is bigger. 5 minus 4 is 1. And then add 1 to both sides. Equals what? Yeah, because now you have to get rid of this one. You have to add 1 to both sides. You were almost there. You need one more step to go. You were right here, you stopped right here. But you have to get x by itself. So you have to get rid of this number by doing the opposite. This is a negative, you have to add both sides. And we can see it's going to work. 2 plus 1 is 3. 4 times 3 is 12. 3 times 2 is 6, plus 5 is 11. So 12 minus 11 is 1. It'll check. Want to try another one of these? Okay. Okay, you're positive. Okay, that's good. What do you do first? Yeah, distribute, get rid of the parentheses. Since we can't do anything inside the parentheses, we have to get rid of the parentheses. 2 times 5 is 10. 2 times 2 is 4. X. Negative times positive is negative. 3 times 1 is 3. X. Negative times negative is positive. 3 times 4 is 12. We have 4x minus 3x, which is x. And we have 10 plus 12. That's a positive 22. Subtract 22. X equals 7. Now, where did your steps go different?
So maybe, from 3x, negative 3x minus 4x,
This one?
not like, after.
Oh, here?
3x.
No, it's a positive 4x, negative 3x.
So, like, 7.
No, it's subtraction. The opposite, since they're opposite signs, you have to subtract. Whenever you have opposite signs, take the sign of the larger and subtract the numbers. No, here's the equal sign.
Finding x that acts like just the two numbers that values like 12.
This one?
That's 12.
But they're both positive. And that's why do the signs and do the numbers differently. That's why I did negative times positive is negative. Negative times negative is positive. And then I do the numbers. 3 times x, 3x, 3 times 4 is 12. If you do them separately, you'll never go wrong. Okay, let's try one more. Let me find one here for you all. That's too easy. That's too easy. They don't have many of them in here at all. I'll make one up. And who knows what the answer is going to be here, because I just made it up. It could be a fraction, it could be an integer, it could be zero. I don't know. I just put these numbers together. I just made them up. First step, get rid of the parentheses. So in the first one, we have negative times positive is a negative. 2 times 3 is 6x. Negative times negative is a positive. 2 times 4 is 8. And positive times positive is a positive. 1 times 4 is 4x. Positive times negative is a negative. There's a 1 here. 1 times 3 is 3. Once you get rid of the parentheses, combine like terms. Negative 6 and positive 4. 6 is bigger, so the answer is negative. 6 minus 4 is 2. Positive 8, negative 3. 8's bigger, so it's positive. 8 minus 3 is 5. Equals 5. Subtract 5 from both sides. We have negative 2x equals 0. And the only way this can be, okay, we can change the signs, but 0 doesn't have a sign, so it's 2x equals 0. Divide by 2, x equals 0. Yes. Get it? So yeah, whenever you have parentheses, get rid of the parentheses, combine like terms, and then move everything around. That's the end of section 12.1. That's the addition property. The multiplication property, we've gone through a lot of the rules already, so we only have a couple of things I want to look at, and we're done with section 2 also. Multiplication property of equality. What this one says is if A equals B, if any two numbers are equal, if I multiply the left side by some number C, and I do the same thing to the right-hand side, it gives me the same answer. So whatever I multiply to the one side, I have to multiply the same number to the other side. It also works with division. If A and B are equal, and I divide A by C, that's the same thing as dividing B by C. So whatever I do to one side, I do exactly the same thing to the other. What do I do there? How do I get X by itself? Yeah, because this is multiplied. This is 3 times X. I have to divide both sides by 3. 15 divided by 3 is 5. And again, if you check it, 3 times 5 equals 15. 15 equals 15. It works. How about that one? How is 6 connected to X? Multiply. So if, since it has a negative in front, the first thing you have to do is get rid of that negative. I move it to the other side. I change all the signs across the equation. Now I do what? Divide by 6. The answer is going to be negative. 6 goes into 7 how many times? With 1 left over. 6 goes into 12 twice. So your answer is negative 12. Right. Make sure your coefficient of X is positive first. And then get rid of the coefficient. So treat the signs and the numbers separately. How about this one? Mm-hmm. That should be negative. So 36 divided by 10 is what? 3.6. Because it's dividing by 10. So you move decimal place 1 to the left. One-fourth X equals negative 12. Yeah, because this 4 is dividing into X. So we multiply both sides by 4. Because the 4's cancel, leaving X. 4 times 12 is 48. X over 3.
All the numbers, right?
This one? Yes. Because whatever's on the bottom, you multiply across the board 3. Whatever you do to one side, I do the other side. 15. Now, subconsciously, what you're really doing is this. Here's what you're really doing. This is some number. Let's say equals C. This number can be written as A over B X equals C. Now, since A is on top, we have to divide to get rid of it. Since B is on the bottom, we have to multiply to get rid of it. So whatever you have in front of your X, you multiply by the reciprocal of it, both sides. Because the B's cancel, the A's cancel, leaving X. So this is what we've been doing all along. Let's look at this one up here. X over 3 is the same thing as 1/3 x equals 5. True? There's a 1 right in front of it, so it's the coefficient is 1/3. What's the reciprocal of 1/3? Yeah. 3 over 1. 3 over 1. The 3's cancel. So we have x. 5 times 3 is 15 over 1 is 15. So whatever you have as a coefficient of x, you simply multiply by the reciprocal of it to both sides. What do you multiply both sides in this equation? 4 over 5x equals 2. Yeah, the reciprocal of 4 over 5 is 5 over 4. The 5's cancel, the 4's cancel, leaving with x. On the right-hand side, before you multiply fractions, always do what first? Simple, reduce. So the 2 goes in the 4 twice. So we have 1 times 5 is 5, 1 times 2 is 2, which makes it 2 1/2. Remember, you don't want to leave your answers improper fractions. So anytime there's a fraction around x, always multiply by the reciprocal to get rid of that. -7 over 9x equals 3 over 5. 2 steps. What's the first step? There's a negative in front of the x. Change the signs. Treat the signs and the numbers separately. Now what do you multiply to both sides? It's already 7 over 9. We have to multiply by reciprocal, 9 over 7. Both sides, 9 over 7. Because the top number here has to cancel with the bottom number. Can anything cancel here? No, 3 and 9, nothing cancel here. So the answer is going to be negative. 9 times 3 is 27. 7 times 5 is 35. There's your answer. Yes.
So, you know, like, yeah, you have to do, multiply, is that only when there's, the whole number in changes to fraction?
Well, you do it all the time. Because let me show, I'll show you the next one.
So you need the 2, 5 and 4, and then the 2 between but on this one, you just call,
When I said, well, all I did here is, since I have fraction here, I made this into a fraction, because now anything on top cancels anything on the bottom. So anything on top cancels with anything on the bottom. So that's why the 2 and the 4 canceled. I didn't cross multiply. I reduced. Cross multiply happens when you have an equal sign between them. This is just simplification. It's 2 times 5, 1 times 4. The 2 and the 4 can cancel. And that's just a rule of any division. If anything on top can cancel anything on the bottom, reduce it. Like this one. Let's do this one. Since it's a fraction in front of the x, make that one to a fraction. If it's easier. What do I multiply both sides by? 7 over 2. 7 over 2. So the 7's cancel, the 2's cancel. What can cancel on the right-hand side? Yeah. 2 goes into 2 once, 2 goes into 4 twice. 2 times 7 is 14. 1 times 1 is 1. 14 over 1 is 14. So that's your answer. Eight over 15 x equals 4 over 5. What do we multiply by? Yeah, it's the reciprocal of whatever's in front of the x. 15's cancel, the 8's cancel, so we have x. What cancels here? Yeah, 4 goes into 4 once, 4 goes into 8 twice. 5 goes into 5 once, 5 goes into 15 3 times. 3 times 1 is 3. 2 times 1 is 2. It's improper, so what does it become as a mixed number? Yeah, 2 goes into 3 one time with 1 left over 2. That's whenever you have fractions as a coefficient. Get rid of those by multiplying by the reciprocal. Solve for x. Combine like terms. 5 plus 6 is what? 11x. 11 minus 2 is, so 9x equals, now what do you do? Divide both sides by 9. 63 divided by 9 is 7. How about that one? What's the answer? -12. A -12 and a +12. Let's look at this. Combine like terms first. X plus X is what? So 2 minus 3, since 3 is bigger, 3 minus 2 is 1. Then you change the signs. Thank you. So the answer is -12. Now, let's do this with addition and subtraction of fractions. Yes, I'll make it easy for you. I'll show you a shortcut for it. Not really a shortcut, but it's an easy way of doing it. Okay. I'm going to show you. I'm going to go over a general rule. Whenever you have fractions and an equal sign. Whenever you have fractions and an equal sign, I don't care what the equation is, whenever you have fractions and an equal sign, find the LCD. Remember what the LCD was? The least common denominator. So what's the smallest number that 5 and 10 both fit into? 10. So once that's what the LCD is. It's the smallest number they both fit into. So the LCD is 10. Second step, multiply each term by the LCD. Remember what a term was? Anything separated by a plus, minus, or equals. How many terms do we have here? 1, 2, 3 terms. So we multiply the LCD to each one of these terms. In other words, I multiply the LCD across the entire equation, both sides. So find the LCD, multiply each term by the LCD, reduce. So the whole purpose of this is to get rid of the fractions. So look at the first one. 5 goes into 5 once, 5 goes into 10 twice. So we have 2 times 2x. 10 goes into 10 once. So we have 1 times 3x. And we have 10 times 2. Nothing cancels there. You see how easy this equation looks now compared to this one? That's the whole purpose of this. Once you find the LCD, it means all the fractions will be gone. multiply to remove the parentheses, and then solve for x. So 2 times 2 is 4. Negative times positive is negative. 1 times 3 is 3. 10 times 2 is 20. Now solve for x. 4 minus 3 is 1. And there's your answer. That always works. I don't care what the equation looks like. If you have fractions and an equal sign, get rid of the fractions. All right, let's do another one here. There, work that one out. What's the LCD? 9. Multiply the LCD to each term. So we have 9 times 2/3 x minus 9 times 5/9x equals 9 times 4. So find the LCD, multiply each term. Reduce. 3 goes into 9 3 times. 9 goes into 9 once. All the bottom numbers are gone. Multiply and solve. 3 times 2 is 6x. Negative times positive is negative. 1 times 5 is 5x. 9 times 4 is 36. 6 minus 5 is 1. And it works. Okay, let's look at. So that does it for section 1. 12.1. The addition properties. And for the most part, 12.2. The multiplication properties. We're going to do word problems, but not today. We're going to do it another day. Section 3. More on linear equations. Let me find some examples that we've done already, but bigger ones. Solve that, please. First step. Get rid of the parentheses. 4 times x is 4x. Positive times negative is negative. 4 times 3 is 12. Whenever you get rid of parentheses, always combine like terms. 4 minus 1 is 3x minus 12 equals x minus 6. We have x's on both sides, so which x do you move? The 1x, the smaller to the larger. So you subtract 1x from both sides. So always move smaller to the larger. 3 minus 1 is 2x. Add 12. Because we have all the x's on one side. 12 minus 6 is 6. Divided by 2. And we have 1 village less. How'd you get the negative sign still in there?
Because I was thinking about doing x, negative x to the negative, the, 3x, but I thought like left to right, so.
No. See, again, that's what you learn in high school. Those are all wrong. I don't care what side it's on. Always move the smaller to the larger. It doesn't matter where it is, because if the x is on the right hand side, you could just flip it and at the end put it on the left.
Yeah, I thought that way. Like I also thought like it's smaller, it would make sense, but I just thought like left to right.
That's why you follow the rules of math. You can't do it unless it's a rule of math. Okay, we'll do one more, and somebody else can see if they lose their village. Eight x minus, in parentheses, 3 plus 2x, close, equals 3x plus 1. Get rid of the parentheses first. So this is a 1, negative, so we have 8x. Negative times positive is negative. 1 times 3 is 3. Negative times positive is negative. 1 times 2 is 2x. Equals 3x plus 1. Whenever you get rid of parentheses, combine like terms. 8 minus 2 is 6x. Move the x's first, the smaller x to the larger, so 3x. Six minus 3 is 3x minus 3 equals 1. Here's the x's. We have to get rid of the non-x's, so we have to add 3 to both sides. And then get the x by itself, we divide by 3. So x equals 4/3, or 1 1/3. Very good. All right, each of these examples we've had so far always came out with one answer. X equals an answer. We call those conditional. Conditional equations. Why are they called conditional? Because both sides are equal only on the condition that x equals 4/3. If x does not equal 4/3, are the sides going to be equal? No. It's only true when x equals 4/3 under that condition. So if there's only one answer, If you only have one answer, then it's a conditional equation. It's true only under the condition that x equals 4/3. Because there are two other ones that are possible. There are two other possibilities. One, you can have infinite solutions. And the other one, there are no solutions. Here's an example here. 5x minus 15 equals 5x minus 3. Work this one out. Okay, so on the left-hand side, we have 5x minus 15. 5 times x is 5x. Positive times negative is a negative. 5 times 3 is 15. We have x's on both sides. So we subtract 5x on both sides. Once the variables disappear, notice there's no more x's in the equation. Once it disappears, we're either going to have infinite solutions or no solutions. Does negative 15 equal negative 15? Yeah. So that means we have infinite number of solutions. This is called an identity function or equation. In other words, no matter what you put in there for x, it's both sides will always be equal. Yes. Here, what you write when they ask for a solution, the solution is this: all real numbers. Any x you can think of is an answer. Let's do a couple of, so we have 5x minus 15 equals 5x minus 3. 5x minus 15 equals 5x minus 3. We'll do a couple of them. Give me a number for x. Let's say x equals 3. So we have 5 times 3 minus 15. 3 minus 3. 5 times 3 is 15. 15 minus 15 is 0. 3 minus 3 is 0. 5 times 0 is 0. So that's true. Give me another number. Let's try 0. X equals 0. So anywhere I see an x, I put a 0. Five times 0 is 0. 0 minus 15 is negative 15. 0 minus 3 is negative 3. 5 times negative 3 is negative 15. That's true. So any number you put in there, positive, negatives, or 0, it'll always give you this equal answers. So that's why it's an identity. No matter what you give me, it's always going to work. How do we know it's identity? During the process, our x's cancel. And then both sides are equal to each other. All x's cancel. Okay, that's an infinite number of solutions. Let's look at, and that's called identity. Let's look at this one. Let's work this out together. So what do we do first? Get rid of the parentheses. I'll let you all do that. All right, so we have 2x distribute to 3. So we have 3 times x, positive 3x. Positive times positive is positive. 3 times 1 is 3. Equals 5x plus 4. Combine like terms. 2x plus 3x is 5x. Plus 3 equals 5x plus 4. Subtract 5x from both sides. Does 3 equal 4? No. So there are no solutions possible. There's no x that we can use that'll make this true. That's called a contradiction. That's called a contradiction because 3 does not equal 4. So no matter what you put in there, there's no solutions. So what are the 3 possibilities? If they're equal, they're called what? They're called conditional. That's when x equals a number. You have one solution. And that the solution set number of solutions the final equation, and this is the type. So the first one we have, it's called conditional. It's when you end up with a number. X equals one solid number. One solution, that's a number. The next one we called was an identity. How many solutions does an identity have? Infinite. So the solution set is all real numbers. And the final equation will be some number equals itself, like 0 equals 0. After you simplify both sides, if both numbers, there's no more variables. If both numbers are equal, then it's identity, and any x you put in there will work. You have infinite number of solutions. Infinite number of solutions. And the last one is called a contradiction. That's when you get things that don't equal each other at the end. Notice there's no more x's. The x's are gone with both of these. All x's cancel. But at the very end, if the numbers are equal, it's an identity. If they don't equal, it's a contradiction. Number of solutions, none. And this is an empty set. Or null set. Those are the three possibilities that we can have whenever we solve equations. What do you think? I just stop here because on Monday we'll have some more fractions, equations, practice ones, and then we'll start doing some word problems. Oh, so that does it for sections 2.1 or 12.1, 12.2, and 12.3.